I'm Therese, and did you know that math is everywhere, especially in rhythm? In this video, we get to know the rhythm of life, all thanks to Ian Stewart's book, Nature's Numbers. In this chapter, we'll get introduced to four concepts, which are gates analysis, oscillation concept, Hopf bifurcation, and symmetry breaking theory, or animals and insects synchronization. Starting off, we have gates analysis, which is the systematic study of animal locomotion, more specifically the study of human locomotion, using the eye and the brain of observers, augmented by instrumentation for measuring body movements, body mechanics, and the activity of the muscles. This study was born from horses, or more specifically from their gait, which is the default patterns of motion that occur when conscious control is not operating. In simpler terms, gates analysis is a study that revolves around the questions: how do animals move and why do they move like that? There is a rhythm to be found everywhere, and we can see it in the way horses run, and we can even see it in the way we walk. Next, we have oscillation concept, which is defined as the process of repeating variations of any quantity or measure about its equilibrium value in time. In biological cycles, the mathematical oscillation concept can be seen as there is a natural dynamics that causes it to repeat the same cycle over and over again. We see this concept everywhere, like the waves of the sea or the bouncing on a pogo stick. The main question asked in this study is, why do systems oscillate? Simple answer is because it does not want to stay still like a caged lion in a zoo. Because it is restless and does not want to stay still, it moves around in its limited space in a simple pattern that math can predict. In relation to oscillation concept is Hopf bifurcation, which is the local birth or death of a periodic solution or self-excited oscillation from an equilibrium as the parameter crosses a critical value. As conditions change, a system that has a steady state, which is an unvarying condition in a physical process, may lose it and begin to wobble periodically. In 1942, the German mathematician Eberhard Hopf found a general mathematical condition that guarantees such behavior. Hopf bifurcation can be found in the playing of the clarinet, as once it is played, it does not need the same puffs of air to oscillate. The last study is symmetry breaking theory, or animals and insects synchronization. In physics, symmetry breaking is a phenomenon in which small fluctuations acting on a system causing a critical point decide the system's fate by determining which branch of bifurcation is taken. In this study, the supposed patterns of gates is broken the faster an animal moves. This theory can be seen in elephants. When it walks with only one gait of movement, but when it wants to be faster, it ambles or moves at a slow, relaxed pace. And that concludes Chapter 7, The Rhythm of Life. I hope you learned something. Thank you for listening.